Hello again, this is Mike Parkman back for video 3 of my Intro to Mechatronics project. This week we're talking about sensors, measurement, and estimation. So new this week in the circuit, I've added in an infrared sensor. It has two lenses, a receiving and a transmitting lens. So how this works is it outputs a light signal from the transmitting lens and then measures how long it takes for that signal to bounce back off an object into the receiving lens, and then calculates the distance to the object with that information. Over here we got an ultrasonic sensor which works very similar to that, except it uses sound instead of light. So the first thing I'm going to talk about with this project is the experimental data that was collected. So here I have distances from 1 centimeter all the way down to 80, and then for each distance there's a corresponding sensor value. When these are plotted, we get the curve over here. So you can see the first 6 centimeters sharply increase, and then we get this decreasing curve. So I was able to build this lookup table here from all the sensor values that I could possibly get. And basically what the lookup table does is says for any sensor value it gives me a distance. So if the sensor's saying 389, it's going to say 13 centimeters away. Or if it says 323, it'll say 16 centimeters away. So we'll give you an example of this working. To connect the Arduino. Okay, so now you can see it's changing there. So that's, I'll give you an example. If I move my hand like this, we can see the distance changing. Okay, that's that. For my second example, I've connected the infrared sensor to the servo motor, and so for every increase of 1 centimeter in distance, there'll be an increase of 1 degree in angle here. And so the distance is displayed onto the LED. So you can see it's measuring the distance to my hand, displaying it on the LED. And we can see the servo motor is moving with my hand. Okay, so I'm able to control my hand control the motor by moving the sensor. For the final part of the infrared sensor section, we were asked to linearize the experimental data collected, and so that was done by just taking the inverse of the distance and then graphing the inverse distance with the sensor data, and that gives us a linear graph like that. So now I'm going to move on to the final part of my demonstration, which uses the ultrasonic sensor here. So now it's going to measure the distance of an object in front of the ultrasonic sensor. It'll display that distance on the LED, and it'll control the servo motors. So the closer an object is, the faster the servo motors will rotate. And as I pull the object back, the motors will slow down. And then after 40 centimeters, the accuracy kind of goes down a little bit, and I'm able to reverse that by changing these two numbers in my code. And so what changing these does is now when I go close to the sensor, it should go at full speed. Or no, sorry. As I move farther away, it increases. Sorry. Yeah, that's what it is. And as I move closer, the speed slows down. So you can see I'm pulling my object farther away, farther away. So that's the third part of my Intro to Mechatronics project, and I'll be back for one last video, and that video is going to integrate all the different things that we've learned this year. So sensors, measurement, estimation, actuators and drivers, and microprocessors and logic, all into one final project. And that'll be the last one, so I'll see whoever's watching this then. Thank you for watching.